Hi America. This is my science in a box. I'm gonna go quick because this one's a pretty intense little experiment. It is what foods will work as a battery. In my box I have my devices, a bag of wires, and a bag of electrodes. The things that are not in my box are the foods that we will be experimenting with. Potatoes are required. It's the one food for sure that's needed for this experiment. Some of the other foods to try are like carrots, smaller potatoes, bananas, apples, lemons, whatever you find in your kitchen. What foods will work as a battery? Inside my binder, I have a worksheet that is food battery data sheet. Set that aside. The objectives of this: students will be able to hypothesize an outcome before doing a science experiment. Students will be able to collect, organize, interpret, and analyze data to produce an explanation of a hypothesis. The focus question is, what foods will work as a battery? I've got my materials in the box. I have a note about safety. It is important that you do not eat the vegetables after you experiment with them because the metals leach into the potatoes. And then just a list of some other safety things to keep in mind when doing experiments. I have the pictures of all the materials again. And before beginning the experiment, students should hypothesize and predict what they think, what foods will work as a battery and what foods will not work as a battery. So step one, inserting electrodes. I've got copper electrodes and zinc electrodes, and I think for speed I'm just going to insert them into 3 potatoes right now so that I'm inserting a nickel and a copper in each end of the potato. So it'll look like this in the end. I've got my nickel, my copper, and it sticks up out of the potato a little because that's what I'm going to connect the wires to. And the next step is the wires. And in the wire bag, I have a couple different types of wires. I've got the wires with the alligator clips, which are going to connect to our devices. And then I have the wires with just the little U connectors on the end. And we're just going to do a single cell real quick. So we're going to put the black wire into the copper electrode and the red wire into the nickel. And this is a complete cell. Once you have a complete cell, you can test it to see if there is enough voltage produced to power this to light a small LED or light emitting diode. And if you look at this diode, it has the 2 legs. One leg is shorter than the other. That's the positive leg. That's going to be what you attach the red clips to. And in this case, we're going to attach, we get no light. So we're going to record that data and add another cell. And when you add another cell, you just take the potato, I'm going to remove this clip, and you will connect the copper of one potato to the nickel of the other using these other wires. These wires, doesn't matter what color you use. Oh, but you do have to get a good connection. Just get in there. All right, and then I'm going to take my alligator clip and connect that to the copper. Now I have a complete circuit with 2 cells, and I'm going to connect my LED and see if I get a light. Oh, I'm not getting a light. I would say normally I would get a small light with the 2 potatoes. I'll make sure. Oh. Well, just record the data with the 2 cells and add another cell. And so the same way, you take the cell, you're going to connect the copper of the middle cell to the nickel of the end cell, or the last potato. Okay, we got it. Okay, connect the alligator wire to the copper. And now let's see if we get a light. And we do. So 3 cells will light the LED. All right, after we work with the potatoes, we're gonna try some other foods. So I'll do it basically the same process using these pieces of carrot. So I'll put a copper and a nickel in each carrot. I'll test whether or not 1 carrot will light the LED, and then I will add another cell, and then I will end with 3. Let me get my wires going here. I'm just doing this quickly. I do copper, to nickel, and then I connect my alligator clips. And I test. And 3 carrots lights my diode. It's very dim. I would maybe try adding another one just to see what the brightness looked like if I was experimenting more with this. Just for brevity, I'm going to set it aside. A banana can also be used. And in this case, I would cut it into 3 cells and repeat the experiment. Let's see. Copper, nickel, copper, nickel, copper. All right. And let's see if a banana battery here will light. Black goes to the long and short. It's a dim light, but we have a light. I've actually found that most of the foods that I've been using light the diode. So I will record my data. Set my food aside. What do we got on? Oh, got 50 more seconds here. So recording all the data, try other foods, and then analyze your data. So what did you learn? We learned how even vegetables such as potatoes can become a battery thanks to a process called chemical reaction. When the zinc and copper were mixed in the potato, it was the perfect place for a current to flow. Now let's get a little more scientific with that. So the conclusion, how does this work? A potato battery is a type of electrochemical battery or cell. Electricity is produced when 2 different metals are inserted between the potato and a salt bridge is created. Potato batteries use the acids in the potato or other fruits and vegetables to start a reaction with 2 electrodes made of different metals. In this case, it's the zinc and the copper that cause electrons to flow from one one to the other through the potato, producing power. The potato acts as a salt bridge connecting to an anode and to the cathode. The chemical reaction creates the electrical energy that can power a small device like an LED light or a clock. And then to conclude, I had the science standard was for PS34, apply scientific ideas to design, test, and refine a device that converts energy from one form to another. And then I've also included a list of some vocabulary words and definitions. And as conclusion to the data sheet, it's, will your potato battery power your small electronic device if you use only one connecting wire? These are just some questions. And what did you notice when you added more cells to the circuit? So I know this has a lot of little parts and it is open for a lot more exploration, but that is my science in a box. What foods will work as a battery? Thank you.